Hello, welcome to the channel. So today I'd like to give a quick overview of clojure.test, some useful functions and patterns from that namespace, how to write your simple tests in Clojure, and at the end of the video we'll take a look at what are the options for the test runners, both for lein and deps.edn. So yeah, let's jump straight in. So when we created our test namespace, the only thing we need to start writing our test is to require clojure.test. And it's actually, from my point of view, just fine to use refer all here. Usually it's better to have an alias, but for this thing, it's so common, like all these macros like deftest and ease and testing, so you don't want to really use alias for that. So once you've done that, you have access to everything from clojure.test namespace, and what we have here is a bunch of stuff, and the most important thing is this deftest macro, and that will be our section for a single test. So if we want to create a test, we do deftest, and then it will be a name of our test. So your test name here, and after that, it's you can put any Clojure code you want here. You can do let whatever x y 1 2, and do your test assertions here. So for test assertions, there is is, and then you have a predicate that could be could return boolean like true or false. If it's true, it means that our assertion is passing. If it's false, it's not passing. So pretty easy. So we can do something like nil x, and if we run that test, it will fail because x is 1, so that's not true. If we want to make that pass, let's say like we want not nil. And now our test is passing. So this is our test assertion. And if you check the output in the REPL, I'm running the test case from cursive right now, and I'm saying to run only one test case under my cursor. So it will just run this one. So it says it run one test containing one assertion. If we add multiple, like is, for example, 1 2, or like 1 1, so it's passing, and we can run it. We see that now it's 2 assertions here. Right, so that's the simple example. Again, 2 simple tests here. Let's remove them and move to the next thing. So if we're using is, the most useful thing here is basically this could be any predicate that returns boolean, right? We already covered that. But the most useful thing is to do equal sign and to have expected value and actual value as first and second argument. So in that case, we can say something like, let's say we want to compare that this map is equal to this map, and it should fail, right? So let's run this, and if we click on this icon, it will show our diff. So left is expected, right is actual, and if we fix this, this assertion is now passing. So again, you can write different test cases here, and also this really, I think that I just discovered when I was preparing the video. I never used that, although I had like almost 10 years Clojure experience. But yeah, I never actually paid attention that in your is statement, you can pass a message at the end, and it will add some more human readable description for your test assertion. And probably it will appear in test run output, most likely. Yeah, so you can do this. Right, moving next. As I already said, the first thing in equal is supposed to be expected. The second one is actual, but that's just makes sense only for the output in your test runners. So if you do the opposite case, opposite order, it will still be a valid test case. So it doesn't matter what you do here. Okay. So the other interesting thing is, it's not widely used, but good to know that there is R, not just is, but R for multiple assertions. And the syntax is a bit weird, but you're basically doing like a let style vector here with your params that you want to use in your test, and then a predicate, and then you basically list all possible combinations that you want to check. So so let's say this should be 2 and this should be 4, and yeah, we compare that these two are same. So if we run this, it's passing, but if we add a failing condition, it's now not passing, and you can see this output. I was actually a bit surprised today that if you add more, the cursive is clever enough that it shows different failures here. So it will be failure 1, failure 2 for different lines in this statement. But as I said, really, in reality, I never seen this R used to be like a lot. So usually you just stick to is and write multiple assertions, and that's fine. And also good to know that this R is actually equals to writing this thing with multiple is statements. Okay, so also if you want to compare multiple values like this in same single like equal, so this is, first of all, this is a valid clojure expression, right? We can compare multiple things, and if they all equal, it will be true. If not, you will get false. The problem is that if this is passing, it's fine. The problem if something is not matching, and if you can see here, you will see 1 and 1, and they are identical, right? But it's basically these two that's not passing, right? But the test runner is not clever enough to, or even test output is not clever enough to know that, because this is basically some predicate that's evaluated. So I don't really recommend to write your assertions if you want to compare multiple things like this, because if something will fail, you will have to manually debug that and maybe create separate statements to check each value independently. So my suggestion would be not try to optimize it like this if you want to compare multiple things, but just write multiple assertions or do some other kind of testing. And yeah, again, so you see the problem like 1 and 2 here, but you don't know about 3 at all. And here it was 1 and 1, but actually this one was failing, so you don't see it in the diff at all. So again, moving next, so we already seen this dev test as like our start of the single test unit. But after that, you can add this testing as a nested layer. It's not doing anything. It just creates a new context, and this will be part of your output. So you, for example, if you have a long test and like multiple things happening inside your test, you can do multiple testing and add some description what's going on inside this block in the test. You can do, for example, testing on this level, some description, let's say, and then some assertions here, and also here, and but you can nest testing as well if you want. Next layer, something like that, and these all valid constructions. The other thing that sometimes is a bit unknown to beginners is what to do if your test function is supposed to throw an exception in some particular cases or input. You can check that with this specific form of is statement, and it's described here. So like a special form will be this condition for thrown or thrown with a message. And it's basically like this is our function that we want to test. And as you can see inside the body, it just throws an exception with some information. And what you can do is you can use this thrown and then put your exception type here, exception class here, and it will pass if this exception was thrown during this function execution. So as you can see, if we put a different random exception class here, it's now not catching our exception from our function, and it throws an exception here, and we have a failed test case. It's marked as an error in our test output. Right, so that's good. And the other thing to know is if you put some meaningful information or message inside your exception, and you just want to be sure that that exception was thrown, you don't want to rely only on your type or class of your exception. You want to do the with message, thrown with message instead, and it will check your regex that you pass in here, and it will check that this particular string was inside the message of the exception. So you see we now have this message inside our exception thrown in the function, and we're checking this. So it's passing now. If I put something else here, it probably will fail. Yes, and now we see that it's not correct. A bit annoyingly, it's not showing you the diff, so you have to debug it yourself. Moving next, more advanced thing is test fixtures. It's a simple concept. The idea is that sometimes you want to run some logic before your test and some logic after your test. An example could be if you're running not a simple unit test, but something like integration or component test. You'll probably want to start your component system or integrant system before the test and stop it after the test. Or maybe you want to spin some test containers or like reset your database, clean up your database before your test runs and all that stuff. So you don't want to put it each time inside your dev tests. You just want to have it as like a extra layer around that. So you can write some fixtures. So it looks like this. You basically define a simple fixture or whatever name you want, and then it will be a function that then gets the function. It's T for the test, or like it could be F, whatever. But basically this function, by calling this function, it's calling the dev test execution itself. So here you have access to this call, and then you can do whatever logic you want before that test and whatever logic you want after the test. And as you see here, I created a state, some random state with an atom of nil, and in the fixture I want to reset the state of this atom to be ready before the test and reset it back to stopped after the test. So now if I and also we can after that we use this use fixtures, which comes from our clojure.test, and there are two options, each and once. So once will mean that a fixture is executed once in the namespace. So you have a single namespace, then you register a fixture with once, it will be called once, and then all tests. With each, it will be wrapping the each dev test and run before and after that dev test. So I decided to use each here, so it's like before and after each test. Let's run this one to see if that works. So this is working, and also you can see output in the terminal. So now as I remove the fixture and I reload the test namespace, let's run this. And now we're getting the failure because the state now is nil from the atom. Again, if we want to re-enable that, we register our fixture, run the test. Now it's passing. And also we can check now that our state, some test state, is stopped. So that's because we run our logic after the test. Cool. I think that's the most things that you need to know from the clojure.test. The other thing is I want to discuss quickly the test runners that you probably want to use. So if you generate your project with lein, so something like new app or whatever, you will have your lein test command out of the box, and probably that will be good enough for most of use cases, so you can rely on that. It's not really configurable, but if you just want a simple one tool, that's pretty good. So the other option is eftest. I'll put all the links in the descriptions as usual. So for eftest, you want to do some configuration. So you want to add a plugin if you're using the lein, and also you can put your eftest configuration as part of your project CLJ. So for example, we can go to some pretty reports, or we can go back to just plain clojure. Oh wait, I'm writing the wrong command, sorry. So for running lein eftest, you want lein eftest, and this eftest command is actually going from plugins. So now you see this output, which is similar to clojure test, and that's because I configured the reporting to be exact same. So, but if we remove this and run it once again, you see the different output in the test runner. So now we have colors and we have slightly different output. And yeah, all the options that's available, you can check the documentation. Things like multi-threading is possible, different report styles, and also a nice feature that will show you your slow tests. If you configure something like if your test is taking more than whatever seconds you want, you can do extra output for those tests. So that's eftest. And the other thing is you can use kaocha as well. For that one, you want your dev dependency now instead of plugin, like this, in the dev profile, and you want your alias. And after that, a command like lein kaocha is available. Again, output is slightly different here as well. And this thing is most configurable from all the options. So, cool thing is that configuration is going to a separate file, test.edn, tons of config here. Tons of config here, as I said. You can configure fail fast, color, reporters, a bunch of plugins. So if we enable this block and run it once again, we should see some profiling from the profiling plugin. As you can see how much which tests are taking. So it could be pretty useful if you want to make your tests fast and you want to debug them a bit. Yeah, again, like all three options are legit, and yeah, it's just like, test runners are doing simple thing. Just search for your tests and run them and do some reporting. So don't spend too much time trying to find ideal test runner. Just better focus on writing better tests instead. But yeah, you know the options now. And as I have here the lein project, if you're using deps.edn, you have the same options, like you can still use eftest, you can still use kaocha, but also if you want a simple option, you can use cognitect test runner. That will do the job as well. And again, configuration in deps.edn is simple as well. And in all of these libraries I checked, there is an instruction how you use it for both lein and deps.edn. So that should be pretty obvious how to do. And yeah, I think that's it for the video. I hope it was a bit useful. Don't forget to like, subscribe, and comment. And also, there is a Buy Me a Coffee page where you can support my work. Thanks a lot. Thanks for watching, and see you next one. Bye-bye.